Now sometimes you get limits where you're taking 0 to the 0. So if I look at the limit as x approaches 0 from the right of sine of x over x, that's of the form 0 over 0, 0 to the 0. And remember, I need it in the form 0 divided by 0 or infinity over infinity. So we're going to do the same trick where we let y equal the limit as x approaches 0 from the right of sine of x to the x. And be very careful with your parentheses here. Now I'm going to take the natural log of both sides. So the natural log of y is equal to the natural log of the limit as x approaches 0 from the right of sine of x to the x. Now you remember log is continuous, so we can pass the log inside the limit. So this is a log of sine of x to the x. Now I can use some log rules. So this is the limit as x goes to 0 from the right of x log sine of x. Now let's look at this. This becomes 0 times infinity, which tells me I need to do some manipulation. So the trick, you remember, let me extend my page here, is I leave the log in the numerator, but I can easily make this x equal to 1 over x. So now I've got the log of the sine, so this becomes infinity over infinity. It is indeterminate, so I can use L'Hopital. So I'm going to let f of x equal the log of sine of x, and g of x equal 1 over x. F prime of x is, let's see, 1 over sine of x times the derivative of sine, which is cosine, or cotangent. Well, g prime of x is minus 1 over x squared. So the natural log of y is equal to the limit as x approaches 0 from the right of cotangent divided by minus 1 over x squared. Now, I'm going to rewrite this because it's just an absolute mess. It's the limit as x goes to 0. And I'm going to put minus x squared over tangent. So this is again 0 over 0, which tells me I can use L'Hopital. Now I'm going to switch pen colors. So it's indeterminate. So I'm going to let f of x equal minus x squared, g of x equal tangent of x, f prime of x is minus 2x, g prime of x is secant square root of x. So the limit as, let me do it this way. So the log of y is equal to the limit as x goes to 0 from the right of minus 2x divided by secant squared x. Now if I just take this limit, this becomes 0 over 1. Minus 0, but it doesn't matter because it's 0. So the natural log of y is 1. So that tells me, the natural log of y is 0. So y is e to the 0 or 1. And that tells me the limit as x approaches 0 from the right of sine of x to the x is 1.